Okay, so we're going to be doing surface area of solids of revolution. And the game is kind of like this. Think about this back in the day. If someone asked you to find the surface area of a cylinder, the outside, the lateral area, technically what it's called, okay, you would do 2 pi times the radius, that is this radius across here like so, and then you would multiply it by the height. Okay, so that's how you'd find that lateral area. Well, surface area is very similar to that. So if I have a solid of revolution, it looks something like this, where I have y equals 2x minus x squared. So it's this region here, wrapped around the x-axis. Okay. Well, think about this, friend. What would your radius be? Well, your radius would just be y, which is that. So there's your radius. And your height, well, for God's sakes, your height is the arc length. So you mean to tell me, Jay, that all I have to do is do 2 pi times the integral from a to b of my function of x, which is my radius, that's my height, that's my radius, I mean, times my height, which is the arc length of that said function. Yeah, that's all there is to it, friend. Well, this just won't take long at all. No, it won't. So in this case, it's going to be 2 pi, and we're going from 0 to 2. That's where it crosses the x-axis. It's 2x, and then minus x squared, and then times the integral of 1 plus 2 minus 2x squared dx. And for this section alone, I'm going to allow you to go ahead and use the integral function in Desmos or TI-89 or 84, whatever you happen to have, because these ones will never integrate nicely unless there's some special fancy trig ratio ones where, you know, you're like, okay, well, they'll have this special case, and it's neat that it works this one special case, but 99% of the time they do not work. So as a result, anything that's interesting you can't do. So that's why I always have you use those kind of deals. So the outside surface area of this is 10.96. That's square units. Another one maybe, like, oh, Jay, what about this one? Like so, where this is x equals ln of y. And I want to find this region here where it goes all the way up to y equal 5. And of course that's 1 right there. I want to wrap this bit around the y-axis. And I want to then find the surface area. Well, glad you asked. Of course it's 2 pi from a to b, of course. And then it would be your function of y times the square root of 1 plus f prime of y squared dy. So let's try that. It's going to be 2 pi, and then the function of y is ln of y, and then the square root of 1 plus 1 over y squared dy, and again that's not from 0, we'd be screwed if it was from 0, it's from 1 to 5. Okay? And let's see what that comes out to be here. So, clear. So, 2 pi integral 1 to 5 26.86 is your answer. And again, not terribly difficult to do them, not terribly difficult at all. Someone might well ask, well, what if I had one of these dudes, something like 10x minus x squared? And you notice I'm doing some fairly straightforward ones because that is actually how your book will do them as well, and that's not a problem. But what if I had this fella here, y equals x? So I'll take this region here and wrap it around the x-axis. Okay, well, if I wanted to do that, then I would be very specific in what I'm looking for. Specific. Do I want the surface area of the outside or the inside, or both? And so if I didn't say anything else, I'm just looking for the outside, but I will always tell you. So if I was only looking for the outside, it'd be this function here. If I wanted to look for the combined, I'd be dealing with both of the functions, and I would be adding them together. So, for instance, the combined, turns out these guys meet at 9, 9. I'd be going from 0 to 9 of 10x minus x squared, square root of 1 plus 10 minus 2x squared dx. That's the outside. And then if I was going to do the combined, it'd be from here to here. We do a combined surface area frequently. For instance, when you do the, not necessarily in calculus, but in real life, because like when you have ice, if there's a hole in the middle of your ice cube, it will melt faster because it has more surface area. If you have to paint it, well, does it matter if it's hollow? I don't know. Are you going to paint the inside? Yeah, well then it matters if it's, you need to know. Okay, but it doesn't really change how I'll go about it. It's just it's a pretty straightforward little problem there. Someone might well want to know how I would find the surface area, you see, of something like this. X squared over 9 plus y squared over 16 is equal to 1. Now think about that. I got to get 2 pi from a to b, whatever that is, okay, and then I need a function of x or a function of y, one or the other, then 1 plus f prime of x squared dx. Well, since I went to the trouble of writing it this way, I think I'm going to solve for x. So I'm going to times everybody by 144, which would be the common denominator. So it's going to be 16x squared plus 9y squared equals 144. I'm going to go ahead and solve for y because whatever. Got to solve for something, I guess. Stupid. There you go. Had a babe. And then square root that. And so what you'll end up with is 2 of these guys. Okay? But the way I've done it, I've got a top one and a bottom one. Well, in essence, if you think about it, what was it? X squared. So if you think about it, what I've done is I've actually got the top one. So I got y equals the square root of 144 minus 9x squared, no, 16x squared, huh? Nice, you see that? And now I've just taken and I've just rotated that across the x-axis, and of course it goes from -3 to 3. So let's do this thing. So it's going to be 2 pi, and this square root of 9 on the bottom I can bring out front as a 1/3. I'm just feeling lazy today, so I think I'm going to do that. I'm going to go from -3 to 3, and then that's going to be, of course, 144 minus 16x squared. Someone is going, hey, Jay, do you mind if I use a trig substitution? Hey, dude, you knock yourself out. I don't think it works here, but you knock yourself out. If that's what you'd like to do, or you'd like to try that, have at it, brother. I'm not fooling with it. And that should be our answer. Okay? Now, someone might well want to know, could I have solved for x equals here? Yeah. And you would have gotten the right half, and then you would have rotated it across the left half. The difference, of course, you'd have gone from -4 to 4 in the y direction. Okay? So let's check this out. Notice I will not be multiplying by 2. I will not be multiplying by 2. Some people would think that. But remember, I just want the top function because I want to rotate it over the top of the x-axis there. I apologize, the old allergies are hitting me hard today. Cannot seem to stop. And that's 144 minus 16x squared. And then times the square root of 1 plus parentheses -32x squared. Dun, 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 dun. And that should be it. That's the surface area, remember, not an arc length. Not the distance around that thing. That's simply the that's not the distance around it. That is the arc length of it. That's the arc length. This is the surface area. I mean, God, I keep saying the wrong thing. Okay, that again, square units there. All right, right. You'll be given one like this today. I'm not going to take the fun out of you getting to do it. I know there's one like this on the homework. Ouch, hurt. And I'm going to go ahead and just kind of draw it up here and let you kind of look at what it would be. So it's x to the 2/3 plus y to the 2/3 equals 1. Okay. And if you graph it, you end up with something that looks a lot like this. Shoot. Okay. And so again, what are we looking for here? Well, what we're looking for is surface area. Okay. Now, if I wanted arc length, it'd be pretty straightforward. But wonder what the surface area would look like. Well, it's x to the 2/3. Try again, Jay. X to the 2/3 power plus y to the 2/3 power equal 1. There it is, right? You're like, well, I guess that's kind of neat, but what, can I just do part of it? Yeah, you can. So what I would do, because of symmetry, and this is, I think, a beautiful thing when you have symmetry, it's kind of neat to do. If I were to solve this but keep in mind now, if I were to solve this for y, I'm going to get something that looks an awful lot like this. I'm going to go parentheses 1 minus x to the 2/3 power, yes? Right? And then I'm going to raise it to the 3/2 power. Oops. You see that? In order to solve for y. Okay? Now, what I can do is I can do two things here. So first of all, I can just do the top half, times it by 2, and I'll get, I'll take that top half, rotate it over the x-axis, I'll get it just fine. That's great. That's one thing I can do. I could also, oops, no, not there, Jay. How about you do it down here, you dingbat? I could also do this, where I said 0 is less than or equal to x, less than or equal to 1, and I'll get just that piece right there. And then what I could do, if I wanted to, is rotate that down over the x-axis first. You see that? Just rotate that down over the x-axis, and whatever I get for my answer, double it. So it makes no never mind to me how we go about it. I kind of think I want to do it the original way. Just let it go, let it go all the way from -1 to 1, and we'll try it from there. So let's write this down. So I get y equals 1 minus x to the 2/3 to the 3/2. That's my function of x. So then my arc length, my surface area rather, I keep saying arc length, my surface area is going to be going from -1 to 1. And it's going to be that function there times the square root of 1 plus the derivative of this mess. Now what is the derivative of that? Well, it's going to be 3/2, 1 minus x to the 2/3 to the 1/2 times -2/3 x to the -1/3. Oh, that's gross. Is that right? I believe that's right, friends. So it's going to be 3/2, 1 minus x to the 2/3 to the 1/2 times -2/3 x to the -1/3. And call me lazy, but these pieces here and here will cancel out. And the negatives isn't going to make any difference because I'm squaring it anyways, but we'll go ahead and leave that in there for right now. And there we have it, dx. Okay? This one's too hard to memorize, so I'm going to pay attention to what I'm doing when I'm typing. Oh, shoot. Well, oh well. So 2 pi integral of from -1 to 1 of parentheses 1 minus x to the 2/3 to the 3/2 times the square root of 1 plus parentheses 6.9. So that should be the surface area of that beast. Notice what happens if, let's see what happens just for fun, see if we can make it work. I'm feeling cocky tonight, so let's just see if this is going to do it for us. What would happen if I just went from 0 to 1 instead? I'm just curious. Let's just see. Some people will be like, Jay, you're living on the edge. What did I say? It was 6.9 a minute ago. I think that's what I said. Yay! Jay did something right for a change. Woohoo! And with that, I'm going to call it a night. Hope that helps. Let me know if you have any questions.